and we developed it from scratch, and we are very proud of it. So first of all, we start with why pure. Yeah, as the Korean covered already, we are invited a new business model which we call evergreen. This business model allows you to own the storage for infinity. So you don't need to rebuy the storage, rebuy the capacity. You just get the subscription for innovation, and after all, every 3 years you will be upgrading hardware, and each software release you will be upgrading features. That's really cool business model, and we don't see it yet from other customers. The next thing is customer experience. So how happy customer are with Pure, and there is an NPS score. The independent organization is measured, and we have very high, let's say, satisfaction with our products. So customers are really happy with our product, and they trust us and believe in us. And next thing is technology. So we are the leader in Magic Quadrant for 4 years in a row, and now with merging the disks and the all-flash array in one quadrant, we're still in the leaders, but we have some gap with execution. And all that built a unique culture within Pure. So we are focusing on those 3 things, and that's allows us to deliver the best product in the industry. This is how we perform. So the best product is okay. Did it sell well? Yes, it sold very well. Customer wait with money for our product, and we are one of the few companies who reach 1 billion in just 5 years. So it takes us only 5 years to be able to have 1 billion in revenue. This is really cool. We will talk about FlashBlade, but before the FlashBlade, we will talk about what is the FlashBlade for? What's drive the Pure to develop this product, and why it needed. We are now living in fourth industrial revolution. That's the data is in new oil. So the data become very important, and the most data we have right now, 99%, is not the data that is delivered by human. It's data that delivered by automation, logs, on CCTV cameras, all that stuff. So humans are not related to the whole majority of the data that's already there, and that's an interesting thing. Some examples to be able to improve. Yep. To be able to improve the search engine, but we need 10 million more data to be able to improve the search for 1%. So just imagine how many data you need to be able to improve something for 1%. And all this data that already there, it's cold data. So it's a backup. It's something that you store, logs, and so on and so forth. You don't use it, so you don't have any value from this data. You don't have any money from it. And this is the reason. This is the idea how it will work in the future. What you have right now, for sure, you have a backups. Yeah, the backups is one silo when you have your data. Maybe you have some data warehouse. Actually, you should have it for reports or something else. So it's the same data, but it's in another location, in our data storage in our place. So you have two copies of data and they are in silos. You have the stream analytics, maybe you do, but it's a different things, yeah. And you have this silos of data, so actually that's a same copy of your data, but they are not working for you. They just sit there. They use your capacity, and that's it. Uh, the reason why you are unable to get this old data together is that the requirements for this data is different. So for backups, for example, you need a random read and you need a scale up architecture. For data lakes, you need a scale out and sequential, and so on and so forth. So for every type of data, you need the different requirements for your storage, and it's not so easy to put this data into single place, to make it not silos, make it one copy and available for all that processes and all that things that you have. So for backups, the high throughput is essential. For data lakes, the seamless native scale out is what they want. For the stream analytics, the performance for different size IO sizes is very important. And for AI and machine learning, the massive parallelism, because the GPU have the massive parallel, and you need to feed this GPU with the data. So the FlashBlade was developed like an answer to all that type of challenges that you are facing when you try to combine all the data together. So first of all, high throughput. So FlashBlade have it. Simple and native scale out. Yeah, you can scale from 7 blades to 75 blades. Performance. You can get throughput, you can get IOPS, and you can get it with the same box. And massive parallel, yes, it's distributed database inside this. So you now can consolidate all your silos, all your workload with a single box, with a single scale-out system. So even if it's backup or software development or data warehouse or data analytics, every task, this silo could live inside of FlashBlade. That means that you will have a single platform for all that silos, and you don't need to make a copies of data anymore. So there will be data, and it will be in the same place and available for all your platform you have. Here's an example from Ion. The Ion have huge installation, and the reason for this huge installation for hard drive was a bandwidth. They need a huge bandwidth, and they're able to reduce the footprint from 50 racks to 4U, and they get the same bandwidth. The same idea with the backups and rapid restore. You have a old architecture when you have a disk inside the drive, inside the servers, and you need to have 3 copies of database, 3 times copies for parity and for disaster recovery. And if you were able to consolidate it with a FlashBlade, you will release the power of your CPUs. You will be able to get more density, and that means more customer inside the racks, and you will save your power and cooling and the rack spaces. The next example is Element IE. What was the issue there? They had GPUs, the massive parallel things that need to be fed with data. So GPU was used for the AI and machine learning, and to be able to build the models, you need to push the data to these GPUs. And before FlashBlade, those guys have been able to achieve the 12% of GPU busy level with the existing storage. With the FlashBlade will be able to give as much data as they want to this GPU, and they have 100% utilization. That means they are start to be more than 5 times productive than they was before. That's really cool. Since launch is in 2017, we have many customers from different parts of the world and from different industries. It's like a Breadcom, chip makers. It's like Domino Pizza is a pizza maker. Zenuity is self-driving cars. So ServiceNow is a cloud-based company for delivering software as a service. So all those companies believe in us, and we are becoming an industry de facto standard for all that areas like modern data analytics, AI, and data warehousing. So idea is to consolidate all your workloads that are living in silos to one box, to one data hub, and that's allow you to change many things. So you don't need the many copies anymore. You will be able to provide a fresh data, and you will be able to do many things that you were never done before. Let's go deep into the hardware, and before that, I will answer the question live. The InfiniBand, yeah. No, it will not be supported. There will be 2 options that will be supported. The first option is supported already right now, is NVMe over the Fabric via Ethernet. It's Rocky Virtu RDMI. It's already available for 2 years, I would say. So you need RDMI network adapter, and that's it. And the second option that will be available at will be NVMe or the Fabric via 5-channel. It could have InfiniBand. It would have just with a regular Ethernet 100 gigabit Ethernet. ARI didn't have it because on top of the ARI there are 2 100 gigabit switches. It could be Arista switches, it could be Cisco switches, so they are not InfiniBand. And you could install in the GX, you could install InfiniBand, but you also could install the regular 100 of 30 gigabits switches. We can discuss it maybe a little bit later. Let's try to describe what hardware do we have. Okay, the FlashBlade. It's a blade. So in the chassis there are 15 blades. It's Purity FlashBlade is a software. It's massively distributed and massively scaled software. And at the back end, there is a fabric, scale out fabric, so you can scale out from 1 chassis to 5 chassis. And that's not the limit. So maybe you will be able to scale out to 10 chassis in the near future. That's how it is. The heart of the FlashBlade is K-value database. It's massively parallel, and the all protocols that are released with the FlashBlade are the native protocols. So there is no any translation, any gateway for the object protocols like it was with the ARM lenders. So the objects sitting right next to this massively parallel, massively distributed database, K-value database. The NFS itself is an ARM protocol that we support. So the same story here. It's sitting on top of this K-value database. That's allow you to be able to get near the same performance result with the objects and with the files. So scale up. You can start with the 7 blades. It's a half of a chassis. You can then go with 1 blade addition to 15 blades. You can add another chassis, and each time you will be adding the blades, you will be adding the capacity itself, and also you will be adding the performance. So as you see, the throughput will be linearly increased when you increase the number of blades. There are no needs to do anything with this adding the blades. Everything is done automatically. Everything is distributed automatically, and when you add the blades, it starts to redistributing the workload around this blade. Performance. There is no any issue with the small blocks. There is no any issue with the large blocks. So we can handle any variety of the blocks, and once again it will be massively parallel, it will be distributed across all the blades, it will be after tuning for delivery of the absolutely great and the best performance. As with the flash array, we introduced the direct flash. What does it mean direct? It means that we talk directly to the flash and we skip this chip, and that will do the translation, do the garbage collection, on all that stuff. We are going directly to the flash NAND chips, and doesn't matter which drive the competitors will put in their array, they still have to pass this layer, and they don't even have these benefits that we will have when we use the raw flash instead of using the disks. Maybe it's mini disk, it doesn't matter, because there are still translation that is happening when you use the disk, and we use the special models that are directly connected to our software, and the software can reach each chip and each NAND module directly, skipping this translation layer. That's really cool, and it allows us to do the massive parallel. It allows us to do distribution and all that stuff that we have. There is no any limitation with file system or something like this. The database we use for storing the data is allow us to do the native object, native file systems, and allow us to scale to billions and billions of objects itself. So as I said, you can start with 7 blades, and you can go up to 75 blades with a single namespace and actually with a single IP address. So you will have 10 petabytes with data with the single IP address. That's all these features allow you to consolidate your task that was not consolidated before in one place, and be able to use this data, not copying it, but do it at snap, do it at cloud, and it's allow you to have one set of data that always will be actual and used for a variety of tasks. Here is a result of the speed result. So with the increasing of number of blades, we increase in write speed, we increase in read speed, we increase in write speed, and we go linear with it. What we have, each blade can be 70 terabytes or 32 terabytes. So you can have 1 petabyte in 15 blades. It will give you 1.5 million IOPS, and it will give you 15 gigabytes per second bandwidth. We support variety of protocols: NFS, SMB, S3, HTTP, and Flash Purity is connected to Pure One, so our cloud monitoring and reporting and system. That's really cool because it's the same interface that you have with FlashBlade and FlashBlade. And yeah, power and cooling, you have only 4 rack units, and you have 2000 watts with a full loads. Inside the blade, it's x86 computer. It has system on chip with compute chipset and with low power design, memory connection to the fabric, and the heart is the flash itself, the integrated flash with integrated NVMe RAMs. So it's all on board. It's directly available from CPU. There is no any translation or something else that's going on. How it looks from the other side, there are 2 switches, and all communication and all cabling are inside this base, so there's no cable outside. Only 8 40 gigabit connections go outside, and you can have up to 5 this chassis connected to the 2 top of the racks 100 gigabit switch. At the end, you have 16 uplinks. It would looks like this. So every chassis will be connected to the top of the rack, and from the top of the rack, you will have 16 100 gigabits uplink to your data. It will allow you to have 75 gigabytes per second bandwidth, and really nothing else can be done here. It's single space, no need to tune, no need to do any special things, no need any special knowledge. You just plug it and run it. That's it. It's a single space, so you will have a huge single space with one IP address. The purity itself, the protocols. We start small. We are adding protocols. Version Purity FlashBlade version 3 that was released right not far from here, and we will add replication, and we will add other protocols. But for now, we have S3 and HTTP for object, and NFS and SMP for file protocols. Also, you may use REST API to be able to provide the space and sharing without any interaction with GUI. Inside blades, we have a compression and thing provisioning. We have a snaps that we can use for backup restore or analytics or other stuff. We have encryption. We always encrypt everything. So if something wrong with blades, it's gone. Nobody will be able to read all the data out of there, and it's really nice and cool design. Also, we're proud of the one thing with the object. We are invite the such term as a fast object. So we was the first guy who did the object fast, because before it was the object store was big, was slow, and wasn't really for the doing such things like analytics or machine learning. It was for archiving, for cold storage, for backup. That's it. So we are invent the fast object. The fast object really cool, because if you have a storage that are able to give you data, the faster you now can do many cool thing with this data. And that was the case. That was the case that the company are using the FlashBlade, and they use it for be able to store the object and to be able to access this object fast. Evergreen. We have a part of Evergreen here too. So we have the love your storage guarantee. So if you don't like a storage, you can return in 30 days. All software is inclusive. We don't have any software that we sell for the price. So all the features are included in all the FlashBlades, and all the future release also included. For a Flash, the flattened file maintenance will not increase the maintenance. You can have a maintenance for the 1 year, for 2 years, for 10 years, doesn't matter. It will not be different. The capacity you can upgrade 8 or 17 or 32 terabyte with some other blades that will be released in the future, and it's non-destructive. So Evergreen is also work for this product too. And yes, we have Pure One. Pure One is really cool thing. It's cloud-based monitoring and support and predictive analytic and reporting tool. It's really cool. If you don't see it, ask for a demo. We'll show you. And all our products, it could be FlashBlade, FlashArray, FlashArray X, FlashArray C. It could be Cloud Block Storage. All our products are connected to the Pure One, and they report the data there. So you can, as a customer, or see all your data in one place, and you can do magic with it. Actually, that's it from my